The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the lower East Rift zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Maunaulu eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? And it was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Wednesday, October 30th, 2024. We're one day earlier than our normally scheduled time because of the Halloween festivities that occur here on Hawaii Island. So we'll give you guys our regular update today with a little special a historical recap on a 1967-68 eruption at the summit of Kilauea. And we might do that in a little less time than usual and let you guys get back to your regular Wednesday. So all that said, how you doing today, Dane? How's your week been?
Oh, doing pretty good. Been pretty busy actually with Hawaii Tracker. The comet photos have been bringing in a lot of new members, as well as the first snow up on Mauna Kea and the photos of that. So I'd like to shout out all of our photographers that have been sharing their images with us over on Hawaii Tracker's Facebook group. And yeah, otherwise trying to stay dry, and also looking forward to Lou's ASL interpretation tonight.
I don't think that's going to happen.
We do appreciate our interpreters who are not with us tonight, of course. So we'll continue on as usual, though. All right, so should we get into our summary, Dane?
Sounds good.
All right, and as usual, Dane will be collecting questions for discussion, leading discussion on the chat, and all that good stuff. I'll do helping that as well. So let's get our screen rearranged here and set ourselves up for our summary. Hello, everyone. This is our Hawaiian Volcano summary for October 30th, 2024. Kilauea's earthquakes that ramped up last week in the East Rift Zone have cycled back down in the last couple of days since the start of this week. And this seems to resume the previous pattern we had before the recent eruption at Nāpau, where we had these pulses of injection of magma underground that would ramp up the earthquakes and then let them ramp back down again as well. So we'll see if that pattern continues, but that's what it resembles right now. Earthquake counts for the last month per day, you can see have gone down here to closer to what they were previously to that ramp up last week. Looking at our earthquake map, the earthquakes are in more or less the same places. We still have that cluster near the eruption site at Nāpau. That's our primary concern there. But also we've seen earthquakes in this East Rift connector area and in the caldera itself to some degree as well. You can see that over the last week, there's been a lot of other events here in the flank boundary between Maunaloa and Kilauea. Also on the south flank, that's just seaward of this active zone of Kilauea with the summit and East Rift here. So as that fills with magma, it puts pressure on the south flank, which then wants to wiggle its way seaward, and it causes these little earthquakes here. If we look at the tilt meters that show us what part of the volcanoes are inflating, we can see here that the Sand Hill Station is showing the Halemaumau area inflating slightly here. And the South Caldera also inflating at a similar pace, and that's different than last week when we saw them working in opposite directions. This past week, or the more recent days here, have been in sync. So the summit is taking most of the magma, it seems like now, because further down, we can see at the escape road tilt meter, things have gone from being somewhat flat to now decreasing over the past week in a direction where we've seen signals with recent intrusions. And further afield at the Puʻu'ōʻō crater tilt meter, looking at the green component that looks west towards Nāpau and Makapuhi, we saw that initial pulse registered on the INSAR satellite image last week. The second pulse came in last week in the signals, and here recently, since then, we've been fairly flat. So it seems like the pulse is matching the earthquake count cycling down as well on the East Rift. And we would expect something to resume like it has in the past. So that's Kilauea. Maunaloa has been pretty quiet. There have been a few more adjustment earthquakes surrounding the summit area. If you look at the depth and time plot, you can see that they focus largely in this upper 10 kilometers of crust, with a couple of deeper events as well coming in. All of that is still fairly low in activity, with earthquake counts down from last week where they had just slightly bumped upwards. Now our maximum for the last week has been 3 earthquakes yesterday in the summit region. So still quite low seismicity as the volcano adjusts and continues to refill with magma recovering from a 2022 eruption. So here's the whole last month on Maunaloa, just giving you a clearer picture of the slower long-term adjustment in comparison to the density of earthquakes we see on Kilauea. And that's our Hawaiian Volcano summary for this week. So with that, we'll come to our volcanic hazards, which as usual rely on the VMAP, Vog Measurement and Prediction Project from University of Hawaii at Manoa. There is not a whole lot of gas coming out of the volcano right now, 60 tons per day. It's still enough to cause issues in people who are sensitive and those who are nearby, but the forecast is putting it mostly in the volcano area. We see occasional pop-ups here west of Maunaloa summit and here in South Kona as well, it seems like. So, but overall, fairly low for what the volcano can do. Pretty safe out there and some of the better air that we've seen for a while. And that's really it for the gas. We'll turn to the earthquakes, of which I've just finished summarizing that there are not that many overall. So if we put the last 2 weeks into the bucket here, maybe we can see the overall pattern, the Deep Pahala earthquakes still continuing, a lot of adjustment all around the volcano, but more so in the south, around Maunaloa at a slower rate, but especially around Kilauea. And coming into that area there, you can see that line of the Upper East Rift connector, a little bit more spread out on this plot that filters slightly bigger earthquakes only, and that cluster by Nāpau right there. And so all the same stuff here. If we put it to the last 2 days, maybe what's happening right this moment. It's not quite as active over at Nāpau. You see a little bit still happening closer to the summit here, even though the flank continues to adjust longer term at a different pace than the rift is inflating and deflating. So that's the most interesting thing here with the earthquakes. If we go to the earthquake, the other USGS earthquake page, you can see our most recent event was a 1.8. Let's get into that one. Right here, looks like it's in that Upper East Rift connector, about a mile down, but fairly small at 1.8. If I sort these for the largest earthquake, and now I'm looking at the whole last 7 days in this area, 2.6 is offshore to the south here. 2.4 is the largest one on the volcano itself here, but that's actually a flank event. 2.4 on the west side, 2.3 over here. So really there's not a lot of very big earthquakes. Let me find one here. It's in the East Rift in particular, or in this little area right here. There's a 2.4, yeah, it's that same one. 2.0 right there is the biggest one we have, near that 1.8 just now. So pretty slow at this moment in time, but it could be that even tomorrow we see the earthquakes ramp back up and all this is moot. But that's what we have today as we give you our update, and that's the earthquakes. And we'll move on to other monitoring signals that we have. And we'll talk about the USGS daily update for today on Wednesday. It's very similar to the previous updates we've had. No eruption, weak steaming occasionally visible from the recent eruption site by Nāpau. No other changes at the summit, in the Lower East Rift, or in the Southwest Rift. I've been scouring over the last week the number of earthquakes that occur in that Middle East Rift zone. And here today, they just say that declined slightly from what was reported to be 4 yesterday. So not a whole lot happening out there, and really not a whole lot to highlight here overall. Our most recent SO2 measurement is still from the summit at 60 tons per day back in September, but there's no reason to believe that's really changed. So that's really it. When we look at the analysis, it's still the same language. Data show magma continuing to move at a low rate from the summit to the Middle East Rift zone. And because of that, future intrusions and eruptions could occur as the magma supply continues. So that's our text update. If we look at our tilt meters, a little bit more than the 3 we already saw. Our Uekahuna station is still very wonky and not giving us anything we can believe, unfortunately. Kilauea Iki does mirror the sand hill, so you can see this Hale signal perhaps inflating, whereas the rift signal is not quite so strong here, but this one is sometimes a little harder to interpret. The sand hill, easier, and this is probably the most significant one that we can count. And important to consider the scale here. So within the last 7 days, let's count it from maybe in here, that's maybe 5 microradians. And here we are at the level of, well, maybe just below 8. So maybe 3 microradians within our week. That's a moderate gain here. It's not anything huge, but certainly more than other locations we've seen. So it's still got a ways to go. It's not really climbing that fast. We've seen this plot in the past. Actually, it starts climbing up and it gets steeper and steeper and steeper and steeper the closer it gets to something actually happening or popping. So we're not seeing anything like that yet. So escape road, as we mentioned, the long-term rate is usually down on both of these components. And we've seen this green component pointing off to the east, to the west here, east and west. Picking up magma coming into that, I don't know what to call it exactly. It's not really the Maunaulu reservoir, but that area near Maunaulu that was collecting magma and causing the recent intrusions. So since this has been picking that signal up, and when it's flatlining, it suggests that it's being fed magma, and then what's going down, it's less so. And so being fed some magma here, then less so. And that seems to be the case right now, a little bit less so on the connector, and a little bit less so over west of Puʻu'ōʻō as well. Going down a rift to Jonica is showing some signal of something happening down there. It's not clear exactly what it is. But we can say that it's not magma, because the magma would have to follow a path across this signal as well, which we're not seeing anything happening there. A couple little bumps, likely the rain that's been pouring across the area here and filling everyone's water catchment tanks, hopefully, but also causing that little bump of the signal. So, and you see a little bit extra flattening of the Jonica signal to the daily variations not occurring because of the weather. But so this is likely some movement of the Earth. It's not quite clear exactly what, some kind of settling or adjustment or shifting. That happens all over the place. But the reason we have this instrument here and what we really care about is whether there's magma going down there, and that's what we can say. There's no gas, there's no other signal that corroborates this. So that's really it. There's one more tilt meter that's down on the south flank, but it's just showing the daily variations and nothing too exciting there as well. Not quite clear if this is some flank movement going on, but in any case, that's the tilt signals for what we have this week. And we like to try to match them with the earthquakes, which have been going down. And while the earthquakes have been going down, we've seen a tilt at the summit. Let's scroll it all the way down here again, right? Tilt at the summit going up, while the tilt at the rift is flatlining. I don't have my other plot here. So there is that plot, depth versus time, with that big cluster of earthquakes that just came in last week and a slowdown with these other events coming in just recently here. We looked at the earthquakes per day in the recent bump. Now that we've had that full last week of elevated events, we are registering earthquakes per week a little bit higher than the previous background we saw over the last month. So that's showing up there, but we're still below earthquakes per month pace than we had over the whole last 6 months. So we're gonna end pretty short in October here, with only a couple of days to go. And yeah, we'll see what November brings. Our GPS stations, unfortunately, are still offline as far as updating to the website. So while there is data being collected there, it's not something we can see or comment on in any way here. But when we last checked in, we saw that the patterns were still reassuringly that there was nothing significant changing since the eruption, right? Because we missed the eruption in here as well. All right, and just to recap how we got here, this is the most recent relevant image when we saw that bump west of Puʻu'ōʻō. It was uplift signal right here. So here's a Puʻu'ōʻō station. Maunaulu is this area right in here. Our escape road tilt meter is more or less in here. And so when we're seeing that area not filling, it's in here not filling, and then in here not filling as well over the last couple of days especially. And instead, it seems to be filling over here. And so if we had a satellite image from right now, that's what we would expect to see, given what the USGS has described. So that's our monitoring signals here. We don't have a whole lot of visuals, but we'll check in on our webcam anyway. Here's a PW camera for the last 24 hours, that automatic GIF that USGS generates. So let's come into the morning here, and you can see some rain clouds passing across. Otherwise, a little bit of steam in there, but not much else to be noted on this camera. The closer one in, here we are, the S2 camera. Coming from overnight to the morning, you see the steaming a little bit more clearly. More fog coming through as well with the rain. And that's all there was to see, really. So not a whole lot going on there. We do have a contribution from Cosme on X, and he is compiling Copernicus Sentinel-2 imagery here. So here is that sequence of lava cooling in Nāpau crater following that eruption up until, so September 23rd, September 28th, October 3rd, October 13th, the very end there. So that's what we have to show you visually for Kilauea today. So with that, we'll move on to touch base on Maunaloa once again. And Maunaloa summit earthquake rates here. Let's come back to the top. I'll show you the last week of tilt. It's showing a little bit of increase here on the summit azimuth, the summit magma reservoir azimuth, the blue one is how they usually line these up, pointing to the summit reservoir. But very low magnitude here, so likely not anything really significant, and possibly part of a larger cycle that's a few weeks long here. There's depth in time for the last week. We had that one event about a week ago. And nothing too exciting. You can see how sporadic these actually are when you zoom into the daily rates here. So nothing too alarming, no migrations, nothing like that. Here's that month-long tilt where you can see this kind of interesting signal here. Right? And not quite clear if that's something to do with the weather as well, or some longer-term cycle, but still not great, not very high magnitude scales on here. So not a whole lot of Maunaloa. I'll maybe wrap up our regular update here and just touch base on the year-long rates. Still low here. It's a little higher last week here. 5-year rates were still quite low down at the bottom. And likewise, our GPS is still out in Maunaloa, so nothing else to show besides the trend had continued from before. All right, so we'll be excited to talk about the 1967 eruption and what we have of it coming up here, but I'll take a break here and pass it over to Lou to talk about our community corner.
All right, sounds good. Let's move some screens around here. Give me a second. There we go. All right, let's get up top. I'm all the way at the bottom. Well, community corner, as you get a quick flash through everything. Sorry about that. There we go. All right. I am, because in honor of tomorrow being Halloween, I know how much Dane likes it, I thought I would throw that up there. Some pumpkins. Let's see what's happening in our neck of the woods, shall we? We'll start up at the volcano up at Kilauea, and we can see up there the sulfur banks are still closed. They're doing work on the boardwalk. The Nāpau crater and campground still closed. They're still going to be doing construction for 2 years or so. And be wary of the yellow jackets that are up there. There's that shot of the boardwalk. Park staff will replace the aging wooden boardwalk to improve visitor safety at Ha'akula. The area, also called Sulfur Banks, is known for bright yellow sulfur crystals that adorn the lava rocks and for other volcanic gases and steam that steep from the ground. I tell you, I like that walk. If you guys have ever done it, it's one of my favorites up there. I don't know if anybody has been watching the calendar at the park, but I took a look and they actually have an After Dark in the Park event up there. The last time Dane and I were in the park, the visitor center was still open. The bathrooms were still open there. So I think that Dean is going to do this presentation of the Great Pacific Garbage Patch. From hopeless to hopeful, dive into the Great Pacific Garbage Patch, a flotilla of trash in the Pacific Ocean the size of Texas. Ranger Dean Gallagher will take you on a virtual cruise that traces the trash items back to their point of origin, learn about the impacts of marine debris and what is being done to turn the tide and clean up our oceans to protect our future generations. This is part of the Hawaii Volcanoes ongoing After Dark in the Park programs and co-sponsored by the Friends of Hawaii Volcanoes National Park. Friday, it says Friday, November 5th. Okay. Now, the reason I left that there is because After Dark in the Park is typically on Tuesday. On their website, they have both Tuesday and Friday. I called up there to see if I can get some verification on there. Nobody could give me a solid answer, and I didn't get a call back. So my best recommendation is if you want to go to this event, please call up there or check the website before going. Downtown is an event. I don't know if you've ever been to a black and white night that's going on downtown. Downtown Hilo, Friday, November 1st, 5 p.m. Come dressed to impress in your best masquerade attire. Enjoy live music, poo-poos, contests, and more at the participating businesses. And see, there's our friends at Tsunami Museum. There's all kinds of businesses that'll be open for this. It's kind of a fun event. I've never been to this one. I've been to a black and white event before. It's a lot of fun downtown. The first Saturday of the month is coming up, November 2nd, and the Tsunami Museum opens its doors from 10 a.m. to 4 p.m. for free admission for Kama'aina. ID is required. Zero Waste Hawaii will be visiting the Pacific Tsunami Museum with information for Hilo's reusable wares system. Interested parties who would like to take classes with him, here's your chance to ask. And that's Kumu Robert Beebe of Lehulu o Hilo, Auntie Doreen Henderson's lineage. Will be showcasing his feather lay experience with small demo display. Enjoy the melodies of local musician Kanoa Fong performing live at noon, and KK and adult face painting is happening down there. And our interpreters aren't here, but I have something. Carrie was spotted out in Hilo Bay for this is the 6th annual Witches Embark on a Voyage Around Hilo Bay on water vessels on a spooky Sunday adventure. This has already happened, but since Carrie had posted this up, I wanted to share that with everybody. It was quite an event down there. It was pretty packed. This photo comes from Tim Wright off of Facebook. And this one, another shot with Mauna Kea in the background. Obviously, it's pretty clouded up. We don't get to see the snow that's up there right now, but still a nice picture. Thank you, Rochelle, for the photos there. And the Volcano Art Center is happening tomorrow, the 31st, Halloween night. Wear your favorite Halloween costume to our spooky trail at Volcano Art Center's Haunted Forest. Your adventure begins with a tour of the Halloween Village. Then your tour ghoul will lure you into the haunted forest. Please bring your own flashlight. This cost is $5 per person, at least one adult per family, free for children 5 and under. It's tomorrow night from 4 to 7 p.m. 7 p.m. That's at the Volcano Art Center at the Niaulani campus up in Volcano. $5 a person. And I put the phone number in there if you have any questions, if you're bringing kids. This is actually the thumbnail off of their video. So if you go to their website, you can watch a preview of the event. That's going to be pretty cool up there. A reminder, go ahead, Phil.
Yeah, so they had that set up for Friday and Saturday. Saturday got rained out, and they rescheduled it for tomorrow. We actually went on Friday. Pretty cool.
Oh, did you? How was it?
Had a great time. Great time.
Yeah, I bet it looked really great. And with the end of the month coming up, here's your reminder. If you're not signed up for our newsletter, scan that QR code, or I'll drop the link into our chat in a little bit. Sign up for it because our new newsletter comes out at the end of the month here. And there are several different ways that you can follow us. Pick your platform. And that'll take us into our survey. And Dane, would you like to give a little talk on that?
Yeah, so this is our kind of annual survey that we're getting going. We did do this survey last year. We had a bunch of responses to it. We're redoing it this year to see where we stand. And if your participation in this really helps us capture some data about all the data we can be able to capture in terms of how much this is helping. And any contribution to this, you don't have to be on Hawaii Island to take this survey. And we go ahead and drop that link in the chat. We'll get that in there. But yeah, we run this survey and we're kind of pushing it for this month to try and get some more people to take it. And if you've taken it already this month, we'd like to thank you. And also, we want to thank everybody that tuned in today, especially on this Wednesday. It's not our normal time. The likes, the subscriptions, the shares, even the views, they all help get the channel growing and help with the algorithm. We'd also like to thank the Puna Strong and Kilauea Recovery that were on there for their continued support for this program, but also our other programs in digital resilience, and now starting up youth development. So yeah, we appreciate all their support, and as well as the Hawaii Community Foundation.
Great.
All right.
There we go. Like Dane said, the best way to donate is through hveri.org/donate. That's the best way to do it. We do take super chats as well, and make sure you've hit that thumbs up and share us out. And that will wrap up our community corner for the week. And I'm going to drop those links in the chat. The survey is already pinned up top, and I'll get the newsletter in case you're not subscribed. I'll put that in the chat right now.
Right, because that's going to be rolling soon.
Yep.
All right. Thank you, Lou. And
welcome.
with that, I think we can. I didn't have the thing in there. I think we can begin to try and move to questions. We have a couple here for you, Phil.
Let's have some discussion.
Yeah. So Buster asked, how deep is the magma chamber under Maunaloa?
Yeah, good question. I think the most shallow one. I remember standing on the rim of Kilauea with Don Swanson, and he says, look straight across, and at the elevation of your eyes, you're looking at the top of the magma chamber over there within Maunaloa, so above sea level. But you can imagine there's probably more than one at different depths below that, depending on the particular time on a volcano or the pattern of filling that it has, right? Just like Kilauea has more than one as well. So yeah, that's the coolest thing that I remember, Buster. The coolest thing I can share is if you're standing on top of Kilauea and look across, and you're about eye level at the top of that magma chamber of Maunaloa right in there.
All right. Next question comes from Nicholas. Asks, why is Pahala's magma flow or magma chamber split into two chunks?
Yeah, the magma flow, probably the most detail that we have so far is that magmatic web paper that came out that shows this actually there's not really a chamber down there. It's a whole bunch of blades and sheets of lava that kind of fill in pulses like we're seeing happening up here in the shallower parts of Kilauea as well. So they track those earthquakes moving through all those various different structures within that area. But I think maybe the answer to the question, I'm not sure what scale you're looking at there for the question. I don't see the question anymore.
Oh, here. Let me get it back.
Or who asked it? Sorry.
Yeah, it was Nicholas. There you go.
Oh, yeah. So, yeah, Nicholas. Yeah. So, not sure what the context is, Nicholas. If it's you're talking like on a bigger scale, like we see a cluster of earthquakes towards Maunaloa and one towards Kilauea. If that's it, then we do believe that there's a split of one path towards Kilauea and one path towards Maunaloa from the Pahala area, right? Plus, there are possibly other paths from Maunaloa that maybe go further straight vertical under Maunaloa and straight vertical under Kilauea, and more from the south under Kilauea. It's almost like the roots of trees coming in from various different areas coming together. But the strong one under Pahala, that one's splitting, we believe actually in three: Maunaloa and Kilauea that you see active now, but also another one towards formerly known as Lo'ihi, Kame'ehua Kanaloa Volcano Seamount offshore. So yeah, that's a discussion we can throw out there. I'm not sure exactly if there's any clarification, but that's interesting to think about, right? When we see that, we used to see in Pahala the earthquakes all in one just big cluster, and over time, over the years, it kind of grew into two separate clusters migrating towards Kilauea and Maunaloa. So it seems like that center part got full enough, and now that the filling part is filling out in each direction as well. So that seems to be the most logical, believable thing at this point, until we get all that seismic data processing with AI and machine learning that's happening right now after the micronode deployment that was put out last year or 2 years ago now. 2 years ago now.
Right. I was just thinking about that, how the what was it, NIFA? She presented at Pahala last January about the collection process and all of the different nodes. And I was just thinking about that, like, man, when's that study coming out? It's got to be getting close, type of thing. Because that's one of the big mysteries is that Pahala cluster still.
Yeah, it takes a while. And you got to remember all those people, after they took those nodes out of Pahala, they went and put them elsewhere across the volcano. So they have more than just that one data set to work on or to feed the machines with. So it's there's a lot going on back there, and try to take a while for us to get all of it out. But yeah, that's hopefully what you're talking about, Nicholas. And yeah, interesting to think about and talk about. And yeah.
All right. Well, I think that does it for our questions and answers for the first part. We will do another segment at the end for any thing that comes up in our special presentation for today. All right.
All right. Thanks, Dane.
Yep.
So speaking of that, our volcano awareness presentation this week is going to be on the 1967-68 eruption. And why this eruption? Because it happened November 5th. And that's coming up next Tuesday, which is election day, and not to mention any politics. But if you want something to think about that's not politics, then here's something to think about on November 5th. And what happened 57 years ago in 1967. And to put it into context, this was in the middle of that cycle of the 1960 eruptions in the Middle East Rift, where there were nine eruptions in that decade. And in the middle of all that, between 6 and 7, there was this 8.5, almost 9 months of lava activity at Halemaumau at Kilauea Summit. So we'll start off by sharing a couple of volcano watches from recent years. So here's one from July 2023, when we still had Summit erupting, but they actually compared at that point the ongoing filling of the Summit caldera and Halemaumau crater to the 67 and 68 activity. So it's interesting. Even at that time in 67, 68, they wrote that the eruption is especially interesting because events be following the same pattern that was recorded again and again during pre-1924 Kilauean activity. So the point being that this happens over and over and over at the Summit, and rather than just leaving it at that, let's try to pick out exactly, when and within which context can that actually happen. And it turns out that when you have the East Rift super active, especially that Upper East Rift and Middle East Rift, that you can have Summit activity as well with just a little bit more buildup of magma in the area. So they note here the two that had preceded the 67-68 eruption were March and December of 65 Middle East Rift eruptions. That latter one at Makaupuhi, if I recall. And there was partially drained magma from Kilauea Summit and caused modest subsidence, they say. At the time, they were comparing this to the post-2018 recovery, where there was similarly a much larger draining and collapse there, but a similar kind of recovery pattern that followed. Because 2 years after 65 is when the Summit Magma Reservoir recharge and eruptions occurred, and 2 years after 2018 also was when the Summit Magma Reservoir recharge and eruption occurred. So those are the interesting parallels. Here you see one of these zoom-in images of that eruption. We'll go through some of the imagery a little bit more in detail here coming up. Aerial view, Halemaumau crater, the lava lake within it. This actually had 31 phases of eruption. We'll go through them in groups, actually like 4 stages, 4 groups of them. But you can see one of the common features in the middle part was this perched pond within the middle of the crater, and it would overflow and send flows out into the outer part of the caldera floor, similar to what we had going on early on in the post-2018 eruption. Not only that, there were magma ooze-ups from the rim outside of that perched pond as the whole crater floor uplifted as a whole. So that's something we also saw in a post-2018 sequence. So it makes sense to make this comparison in this Volcano Watch article that was put out last year. So they note some of they go into some of the monitoring stuff in here, but I don't want to get into that too much. It is interesting to note that in 67, they were still basically putting out a lot of their monitoring networks. So a lot of the stuff that was happening then, I'll show you some of the really consequential conclusions that came out of that still kind of guide what we think the volcano does today. So as an overview, in 67, there were 12 seismometers and 2 tilt meters. The seismometers were live. Tilt meters were done by hand, read manually every 2 to 12 hours. And so by the beginning of the eruption, I think they actually may have had something a little bit more continuous. But that's how groundbreaking the technology was still at that time. So today they say still 18 seismometers and 4 tilt meters, but we also have GPS stations. We also have gas emission stations. We have meteorologic data. We have gravity. We have satellite data. We have rangefinder data. We have webcams. We have thermal imagery. So there's a lot more we have to go on than they had back in 67. So in the end, it was 251 days of eruption that filled the crater of Halemaumau about 370 feet fuller, about 113 meters. And at that time that they had written this article, they were making comparisons to how far that had filled as well. But the caveat being that there were different size holes at different elevations as well. And so there's another one of these views. This is actually, let's see here, yeah, the 2023, June 2023 eruption Kilauea summit, which you can see doesn't look too different from this view back from 67. And there is an aerial view of the 2020 or 2021 eruption in Halemaumau crater with the similar ooze up flows coming up from the sides as well. So interesting to note those comparisons there. So one of the issues that they actually had, besides having that extra monitoring equipment being developed, you can see that the right incline noted that increased challenges to the staff as eruption frequency underwent a dramatic increase. So where more eruptions happening more frequently, kind of similar to what's happening now. And so they're trying to chase all these eruptions as well as develop all this instrumentation and publish all this stuff, and all before there was much computing power to be leveraged as well. So a lot of hard work being done back then. All right, so that's one volcano watch to highlight. I think there's another one that's interesting that goes back to before 2018. So let's look at that. This goes to all the way back to November 6, 2008, when we first saw the opening of the pit of the overlook crater in Halemaumau. That was the beginning of that 10-year phase of magma filling that led to 2018. And so here's a view of that overlook crater after it opened up. But what this article is about is what we'd call that famous bathtub scum ring that was clearly marked across the wall of the crater. You can see from the overlook halfway up with this coloration marking it a lot of the areas here. And that was the height of the lava in that 67-68 eruption. And so for many years, that was visible before the collapse in 2018 at the summit. So here's a little bit of a recap of the sequence. It began at 2:32 a.m. on a Sunday, November 5th, 1967. A line of vents opened north-south across Halemaumau crater, up to a dozen fountains, throwing lava 250 feet into the air with a lot of extra gas, very sulfurous fumes coming out in a large white cloud. The entire crater floor gets covered in a lava lake, rising as much as 12 feet per hour. At night, it glows, reflecting off of the fume cloud, visible all the way to Hilo. As you can imagine, people took notice of that. They didn't need to have a radio announcement or any kind of other broadcast to wait for the newspaper. They saw what was going on, and they came up to see what was going on themselves in person. So there was quite a lot of visitation happening early on, especially. They note that that first phase 1 as it's now called, lasted about 23 hours after filling to 103 feet deep of lava. But what happened, and was typical of much of this eruption, the lava begins draining back into the vents immediately. So it drains it back another 45 feet, and in the end, leaves a bunch of jagged crusts, chunks of islands, all kinds of loose rubble on a surface, which then, when the next phase comes in, will come and flood and refloat some of those things or bury other ones and move them around, and similar to what we saw in that 2020 to 2023 phase of Halemaumau. On November 7th, the newspaper headline declares eruption officially POW, although it wasn't officially POW because there was more to come. They actually had seen inflation already occurring and increased harmonic tremor coming on as well, right? So they believe there was another eruptive phase coming in. The second phase was 11 days, 1,500 feet fountains in the middle of the lake. The perched pool of lava then grows in the middle of there and grows 100 feet high. Now that allows a lot of ramp room and a lot of relief to overflow and spill out into that moat across the edges of the crater floor. So similar thing, lava, fills up. Once eruption ends, lava starts draining back into the vents, which are now stuck in the perched pond. So that's the part that drains. So that drains out 20 feet or so. So that's what they basically had: harmonic tremor, lava coming out, overflowing, deflation, drain back, quiet, wait for more tremor, and come back and do it over and over and over again. And so that's what led them to think, well, are we into a long-term phase of eruption here? What's going to make this actually change? Right, following those 6 East Rift eruptions that they had actually had in the early 60s. So this is all part of more magma coming into the volcano. We now know in hindsight, right, this was going to lead to what eventually would be a shift back towards the East Rift, back to Maunaulu, that would lead to a 5-year eruption in the rift. But at this point in time, they didn't know any of that. So here we have 31 eruptive phases. In the end, it was 84 million cubic meters that went into the crater. Some of the phases only lasted 8 hours. The longest one went 68 days. All right, so by the middle of that, halfway through phase 16, rather than lava fountains, you saw massive bubbling within the lava lakes. And the quiet periods in between lasted between 12 hours and 6 days. During phase 1 alone, almost 22,000 people braved howling winds, chilly weather, choking sulfur fumes, and the sting of wind-blown pumice and ash for a front row view. To manage heavy traffic, the National Park Rangers set up a one-way route around Crater Rim Drive. Pretty smart up there. There was a boost to the island's hotels, tour operators, and rental car agencies. Airlines offered special excursions that circled Halemaumau crater at an altitude of 1,500 feet. Planes were restricted to a counterclockwise pattern, so passengers switched sides after 15 minutes so they could get a good view. Can you imagine anything like that happening today? Maybe a different discussion there, right? But so in the end, when the eruption started, the crater floor was 550 feet deep, and after it was done, it might have been 360. So it might have gained up to 200 feet-ish or so after everything that came out and drained back and came out and drained back and 31 times. What was left behind after that. So hard to measure how much volume it is when it's doing that kind of thing, but that's what the numbers actually mean there in the end. That final drain back left a 50-foot depression in that lake surface. And that's how it looked between 1968 and 1971, when that southwest rift eruption drained the interior of Halemaumau, and it caused that whole crust to collapse. So the interior of that lava lake was still molten in 71. It drained out to the southwest rift. Crater 4 collapsed 150 feet, exposed that high lava mark, and left a bunch of rubble, which was then later filled by lava and later eruptions. So that's the 2 volcano watches we actually have here. Right? So I noticed you guys, just so you know, I'm going to have to take a break here at some point to go and fix my power. So you guys want to talk about this right now for a couple minutes?
Sure.
Yeah, jump in there.
All right. So, bathtub ring around Halemaumau, the old lava lake. So, one of the interesting things was, we've seen these. We saw this in 2018 as well. These those bath lines. We talked about it, where one of the fissures that opened up drained into a giant crack that had existed prior to the eruption. and filled it all the way up. Then as it drains slowly, these bands start appearing on there down the crater wall, so you could see the progress of how it all drained out, and also showed the high lava mark of that point. But it's a lot smaller scale there than when you're looking at Maunaloa crater. Have you ever seen those, Lou? I know it's hard to see up there. You got so much crumbling is the problem, right? Because the walls don't hold; they all crumble in.
Right. So when we spent the 7 days up there, it was one of the things we were, looking for anything that stuck out, and everything's so crumbled up. And when you're up there at 11,000 feet, 9,000, 10,000 feet, you try hard to see things, but up there, everything just runs together at times. And we spent a night between Red Hill Cabin and Summit Cabin out there, Dewey Cone, Steaming Cone. And we were looking, but we didn't see anything. Saw a lot of everything else at times, but.
Yeah. Maunaloa, a different beast, the altitude definitely makes it so much more difficult up there, and the lack of accessibility. There's no road to get you up to the summit.
No.
So you can get kind of close with the observatory up there, but you're still walking that last 2,000 feet, 3,000 feet, something like that,
straight up
summit, which has got some pretty significant slope to it, and a lot of wind up there.
Yeah, that hike was in July, and we anticipated the temperature to be cold, and we knew it was going to be windy. And we've been up at 14,000 feet before for a week at a time. And for some reason, that 11,000 feet just hit us hard in elevation, as well as just the wind was brutal that week. Not until we dropped into the caldera and started walking across there that we kind of get a break. But you lose your I guess you set your goals to look for certain things, but when you're up there in the moment, sometimes you just want to get moving, stay alive.
Right. Yeah. So welcome back, Phil. Just talking. Oh, you're muted.
Hey, thanks, guys.
Yeah.
Where'd you end up at talking about?
A little bit about 2018, and then also to Maunaloa a little bit. So we're just bouncing around to different spots that also has some bath rings, essentially.
Right. Cool.
A little bit different kind of thing, but yeah.
Yeah, so interesting. Yeah, that for a long time there was some trace of that eruption left, but now really you can't see any of it anymore. It's all in rubble on the bottom of the crater there. But I did dig up a couple of old little clips. This is from stock footage, so I'm gonna leave the people's logos on here. So if you want to go find the originals, here it is. This is a view from before the eruption. So this is what it looked like before 67. The last eruption was 61, and here is at 67 eruption in November early on. Pretty cool. See that massive flooding and no perch pond yet. That's that first phase. All the clear wall there. Yeah, a lot of fume visible up top.
Yeah, I've never seen this footage before you dug it up.
And then there's some black and white version of similar kind of stuff from that same era there. So I'll throw that in here also, because the bubbling of lava is not quite as dramatic, but there's a shot coming up here that people are actually visiting, which is not in the other set there. So still, that's what people could see right there, looking down. Yeah, so only a few seconds of the stuff, but that's what there is to show. We have quite a lot of images that we can go through next, but they're not moving pretty like this. I thought I'd share this with you guys first so you can get a little bit of that view. And I can show this again here at the end as well. But to help guide us through this, I just want to share with you what the literature that exists out there on this eruption put up by the USGS. It begins with the inflation portion, by Dick Fisk and Willie Kinoshita. And this lays out essentially that the volcano was inflating for several months ahead of this eruption, right? But remember in 67, they're just laying out the monitoring network. And so they're establishing the patterns that exist as far as we see a bunch of inflation. If it inflates this much, we're seeing actually the amount of movement laterally on parts of the volcano is getting really, really massive. And when we're seeing that, maybe we can actually use that to predict eruptions. Maybe we should start measuring distances horizontally. And so that's kind of where they are at this point in time. And so I won't go into the detail of this greatly, right? But I can show you guys here that they actually have their components. There's 61 eruption, or, no, 65 eruption on the East Rift with a drop in tilt. And then eruption happens at the summit, and much smaller drop in tilt there as well. They go through a lot of leveling and look at where the volcano is swelling. They track how inflation centers move around the South Caldera from the center to the south. So it's interesting to see they caught that early on. We're still seeing that kind of pattern today. And we probably won't go into more detail of all the information that they're seeing here, but this is how they imagined, even back in the late 60s, the island weighing down the sea crust, coming through its magma storage area, being composed of blades, what we call dikes, the vertical ones, and sills, and all these various orientations of sheets of lava. And that one of these came up to the surface, essentially. That's how they imagine that. So maybe my favorite image of this early paper. But they come into here, and so here, just to note the tilt meter comment from earlier, and this is where I get it from. They say, thanks to the continuously recording tilt meter located at the Volcano Observatory, we're able to trace inflation of Kilauea up to the very moment of eruption. So that seems like they had just installed this thing right there. The tilt was studied during the last several hours of November 4th and the first hour and a half of November 5th. And then at 1:33, strong harmonic tremor began recording in the seismographs. No change in the tilt. And then thereafter, 1:45 a.m., the tilt increased, and I can tell you the rate, et cetera there. There were 3 felt earthquakes, 2 that happened before they saw glow, and 1 afterwards, all felt in the area. And then basically say the eruption begins, and then this paper ends, and we then move to the next paper, which is really about the eruption, which is the same group of people, but with the lead author, Kinoshita, that is recounting the actual eruptive phase for those almost 9 months that occurred there. So there's a lot in here. I'll try to highlight what I can, but to go through it, it helps to know that there were 31 phases. So let me scroll down past some of these phase descriptions to show you guys this graph right here. So this is really A is the beginning, November through March, and then B picks up March through July of 68, right? So they kind of go side by side, right? That's what is really going on. The top part here is the ground tilt at Uakahuna, the east-west, corresponding to the summit reservoir. And then down here, this is filling rate. So in meters of filling. So 0, 25, this is 50, this is 100, right? And then down here in these solid black lines, let's get this bigger as much as I can here. These solid black lines are showing what they're measuring the depth of lava to be during that phase of eruption, right? So phase 1, phase 2, phase 3, phase 4. So you can see how long they lasted by the length along this axis, and by how far they go up, how much lava they filled up during each phase. So that first phase you can see filled the most right there. And there are times when you see increases occurring between eruptive phases, and that's when you're seeing a crater floor lifting from below when we're doing these measurements as well. So you can see that it started off fast and furious, lots of phases with lots of pauses in between. And then something changes around 24, right, where you can see the pattern of tilt, deflation during eruptions, reinflation right afterwards, deflation, reinflation, deflation, on and on until we get to right around here, when we basically switch gears, the volcano starts a long-term inflation. So we saw this in our 2020 and 2021 eruptions also, right? At a certain point, we saw the volcano start reinflating while lava was still coming out. It just started coming out at a slower and slower and slower pace, and eventually gummed all the way up, and it eventually stopped. And it seems to be somewhat of a similar thing here. You see the tilt pattern changes entirely. The phases become much longer. until ultimately you have 28, 29, that goes all the way to here. Get longer and longer. 30, look how long 30 is. And when 30, we go out with a very brief 31 at the very end, like a very last burp, as is sometimes the case with our eruptions here. So that's the overall pattern of it. The very first phase, we described it a little bit through that Volcano Watch article, so I won't go through that exact description, but here we have a timeline for November 5th. Tremor, inflation, first earthquake 2.8, second earthquake 3.4, first sighting of eruption 232, tilting ends, last earthquake 2.8, maximum tremor 315. Notice a decrease in lava coming out by 10:30 a.m. Tremor decreases right after midnight, and the phase is called over by 1 a.m. that next morning, reversing to inflation. And then you're looking to see what happens next. And that's when you had that headline of eruption already, pal. And so what happens next? Well, so that first phase left 7.6 million cubic meters of lava in the pit after the drain back, right? Phases 2 through 7 are our next batch that we're going to have. And so there was local overturning in the crust of the lava lake that was already there and weak spatter, but there was essentially no fresh lava coming in, no tremor happening until November 9th, when they saw more tremor. A pad of new lava fed by small bubbling fountains was observed in the center of the lake. Tremor starts coming up, but very gradually, so we're not exactly sure when it begins, so they take a time, but it builds up to higher amplitudes to where they're sure there's a whole bunch of new lava coming out through the vent. The fountains grow from just these weak spattering to heights of 20 to 30 meters. We're talking about 100 feet. For 2 days, really high tremor. The lake is rising 10 feet a day, and then reaching about 100 feet deep in the middle there as well, right? Exceeding the maximum depth during that first phase. And so at that point, that's when you start growing that low levee that starts growing outwards and upwards as well, and that's what's growing that perch pond. They're not using the term perch pond in this paper here, but that's how we describe it today. And so that's what's happening, and that ends on the 19th. The tremor ends as well. Drain back begins. By the morning of the 20th, everything is drained out. By the 21st, it begins again. And so that's the pattern that you kind of get. So 4 through 7 are the same as 3, basically, right? And so maybe what I can do now is jump over some of these images that exist. So there is a National Park Summit Eruption photo gallery, which I've supplemented by some other USGS images that I found. So phase 1, here's how it actually looked. Looking, you can see there's Maunaloa in the background. This looks like it's somewhere in that south rim area, right, towards Kanakakoi Devastation Trail access route, right there. So that's the, in its full glory view of fountains opening up there north to south across the inner floor. There are a lot of other images like this one. It's black and white, shows a very similar thing, but just a little bit different perspective. I'll show you guys. There is a kind of shape of fountain there, and then these 3 over here. So I'll flip it back, and you can see slightly different angle on those things, but same view really we're looking at here, different angle. Phase 1, there's a people overlook looking down the vent, similar to what we saw in that little brief video clip. And another view from phase 1, we see lava all the way to the wall of the crater. Some still weak spattering occurring. Nice flow features in the crust here. Phase 2, after that initial pause, reactivating here in the middle, there's a fountain, see some flows moving out towards the edge of the crater, but there's a clear rim starting to develop in areas right around here. Let's see, maybe can I zoom this in more so some of you guys can see it a little better maybe? And highlight it again. There's that edge right there of the rim, right? You actually can see there's a little overflow happening right there, but there's a perch pond feature is beginning to form. So phase 2, I could not find a phase 3, but I believe this is phase 4. So by this point in time, that perch pond has grown even taller and bigger, growing outwards as well. So here's where it actually sits. This image, here's a giant overflow coming out of that piece of it over there. And the fountain's reactivated in the middle there. Here's a phase 5, I believe. Similar as well, right? Can't see it as well in dark, but there is the edge of that perch pond. There's an overflow from it with vigorous fountains in the middle. It's hard to tell from these images, really how big these fountains are. They describe them being in the order of 100 feet high, right? So this is a really big flow in the crater seen from way above. Not a whole lot of context otherwise, but this one I believe is phase 6. So maybe a little bit more of a dawn lighting. There's that overflow spot right there around the edge of that perch pond, which now you can see is not all the way to the wall of the crater. It's inset by that distance there, right? Every direction. So that's that phase 2 through 7. And then what comes next is a further development of that perch pond. So let's see if I can jump ahead here to where is our phase headings? Phases 8 to 23 here. So there's noting that pattern, overflows, perch ponds, and maybe now I'll focus on this image right here in the middle, figure 3, which is showing what they're calling different stages of eruption. So what they're showing here is the most recent eruption that occurred before 67, 68 was a 61 eruption. That's this thing right here had filled the previous features on the crater floor. So one eruption begins, it puts out lava on top of that and makes a new lava lake, which basically floods all the way to the crater wall, wall to wall, floods all those inner benches as well. Everything gets buried underneath that new sheet, which is basically flat on top, right? But as eruption continues, you start having perched pond walls that migrate across, features like spatter cones being built on top of the thing as well. So that's what they're showing here. And eventually you're also having lava coming in below that crust, moving outwards below the crust and feeding up these ooze-up flows that happen around the perimeter of the crater. Right? And that's how you end up with all those different features on the crater floor, which we're now familiar with since we saw everything happen since 2020 to 2024. A very similar pattern you see there. And yeah, so phases 8 to 23, there's basically more of that perch pond activity, quiescence in between, levees growing. Another phenomenon displayed by the phases 8 to 23 was a rising and sinking of islands of crust contained within a central active lava lake. Before a eruptive phase began, the island masses stood as much as 20 meters, call it 60 feet, above the drain level of the lake. As soon as the islands were surrounded by the rising lava of a new phase, they began to sink. After decreasing elevation of 5 or more meters, they were covered or nearly covered as active lake began to overflow. And during drain back, they ran in reverse as the level subsided, the island masses rose. So observations show the island masses were floating in a pond and not rooted to the floor of Hale-Maumau. So similar to what we've seen in more recent years as well. And interesting to find all those events. So let's just stop right there and go back to our pictures. So here's phase 8. That's that image we saw from earlier, viewed from the air. With a very well-defined edge of that perch pond with some little islands here in the middle of it and a big overflow off to the side there. Phase 8. We have more phase 8 as well. This is after phase 8 ended and lava is drained back. This is the kind of thing you have left behind. You have that perched wall right there. You have these 60 feet tall islands sticking up all across here. And the lava basically sagged back in vents and leaves this lower crust all throughout here as well. And there's one view of that, and another famous view of after the draining here in phase 8 of 1967. By now, we're up to December 5th of this eruption. So up to phase 11, what's the glow look like when lava would reactivate after one of these pauses? They see the glow, they can go over to the edge and look in and see what's going on. So a little bit closer view. There is, let's zoom this in because it's pretty cool moment in time here. They've captured that drained perch pond and lava re-emerging from the vents and refilling that basin. And it's going to refill this entire perch pond and then start overflowing over the side again after it does that. So that's what they were looking at every time. And here's what comes next. The whole thing full, spilling over the edges. So that's December 14th. December 17th here, phase 13. After it drained again, refilled. Here it is, refilling it once again. Islands, there they are, just sticking above as opposed to being 60 feet tall. Right? Don't see an overflow in that phase, but phase 15, nighttime view. You can imagine if these are happening daytime, nighttime. We're running up there all times. Small overflows over there. Phase 16. This one's really cool looking. Really, lots of overflow streams here coming off the foreground of the lava lake. You see a big one on the back as well here. It goes all the way to the crater wall over there. Big flow over there. It's all the way over here perhaps as well. So that's phase 16. Phase 20. Now we're up to January 5th, 1968, but very similar views there. There's a bubbling fountain in the middle, active vents feeding the lake within that perch pond. It's overflowing into the edges. And what we're not seeing so evident here, but maybe we'll see later on, is occasional ooze of, maybe this is one here, ooze of flows, or this might be an overflow around the perimeter of the crater wall right there. So that's phase 20, January 5th, 1968. And this one undated, but it fits into that same era and same period, same visuals, same amount of overflows. So likely that same phase 20 there too. So I'll keep going with the pictures. Just finish them off here. Here's phase 28, National Park image. Right, so but the lava is active within there once again, refilling that pit. There's a different view. A little bit more visible with the color, but also none of the surroundings being at night. Phase 29, well, we're not seeing so much of these overflows, right? It's kind of just bubbling within the perch pond now. A lot of gas coming out there. Phase 29, the last picture I have to show you guys here. It can contain within the perch pond there at the end, a little bit more subdued. So if we come back to our summary paper here, that phases 24 to 28, that's when we saw the first time the eruption accompanied by rising tilt. And so that's when it's basically oozing out, but not all the pressure is making its way to the surface. That's when we see the change, and it's not overflowing and pouring out over the whole crater anymore. It's basically clogging itself up there. So they say that during that phases 24 to 27, the level of the inner lake never exceeded the height of the confining levee. And gradually a new levee was built inside of the one built earlier. That main island mass became part of the new levee and became rooted to the lake crust at that point, with very little or no fountaining there. Right, so that's that summary, and here's some different views of this is the amount of tremor they're seeing and the deflation. So the inflation prior to the eruption begins, deflation, inflation following the end of tremor, right? This one they pulled from Maunaloa because the station close to Maunaulu was unreadable. It was shaking so much at the north pit. So here's what we see in the north pit, the rest of these stations. But here's phase 10, not quite as dramatic, but still showing that deflation inflation pattern corresponding to the end of tremor. Phase 22, a little bit more clear there. Phase 23, by phase 24 to 28, now you don't see it anymore. Now you're seeing this almost constant lower level of tremor with constant inflation with little variations happening as well. Right? So the very last one, phase 31. Let's see, where did that one go here? Phase 31 was 19 hours on 13th of July. after which the eruption was all the way over. So that's the pattern of lava coming out. They're also measuring deformation during eruption, noting there was a lot of deflation around the summit area as lava was coming out, as we now know is normal and expected. But they also noted that there was some inflation happening further south around the Kīlauea area as well. So that's interesting to note there as well. That they note that towards, maybe towards another eruption, as magma is not coming out, the volcano is reinflating. The center of inflation is here towards the south. And so they note then, that's what they say, is they say that the first spot to, or the last spot to inflate the most, and the first spot to deflate after the eruption is over here. So let's keep measuring this distance across here. And so that's now why we look at this north-south caldera distance all the time as exactly the measure of that as a predictive indicator for our eruptions here. So that is most of it here. I'm not going to go into all the chemistry and all the other stuff here, but here they get into this whole, can we actually forecast it? And then they start talking about, what are you talking about? But they do say in the end here that, where is it there? About 1 month before the eruption, they show high deformation south of Halemaumau, et cetera, et cetera, et cetera. A program for monitoring horizontal measurements at intervals of 1 week has been initiated in the hope that it will eventually be possible to predict volcanic eruptions. So you really can see the development phase of this whole era of the Volcanic Observatory. I just mentioned a couple other papers that came out of this as well later on. Particles in the fume of the 67 eruption. We now call this VOG. But before this, people didn't know that in that cloud of gas, you had all these different particles of different components and shards of particulate matter and all of that. So I won't go into the details, but you can see here is that one of the very early papers on VOG from Kilauea from that eruption. And we can go on, and paper came out later on about magma mixing between this, because what I should say that after the eruption ended in July of 68, there was an eruption in August of 68 at Hi'iaka crater to resume the East Rift phase. And so what they found was that the magma from Hi'iaka crater that came out 2 months later and the magma that came out in a lava lake were related, and just one was slightly more evolved from the other. And so that's what this paper is all about. Now this is all normal. We talk about this every eruption. Where did the magma come from? What did it mix with? Back then, it wasn't quite so clear. They had to basically pull this out from the data. And so here's their interpretation. Magma coming from below. There's like some multiple pathways. They have no idea. This is early on. But feeding that Hi'iaka site and the summit site from some common body that has had some distance and time to evolve along the path there. So some examples of this, and I won't talk about what any of these actual data points are here, but some of these are usually read in others. Let me come up here to where we're marking, for example, HM is Halemaumau samples, and HI are Hi'iaka crater samples. So here is a line, this mixing line, and you can see they are on the same trend of mixing as you would expect of a magma to fall, right? So this is this particular ratio. Like I said, I won't go into what these ratios actually mean, but there's one magma mixing trend. Here's another. There's a Hi'iaka and Halemaumau. And here's another Hi'iaka and Halemaumau. And there's another. And so you can see that's consistent across the board and all different minerals that they're measuring and elements that they're measuring there. So all in all, really important for the development of the science, right? A lot of the stuff that we take for granted now was really, they were still kind of nailing it down at that point in time. So I will replay the eruption clips here for you guys one more time. So we can pull it all together. And yeah.
And that model of the magma chamber they came up with wasn't bad, really. Like for the time, like that actually still looks pretty decent. Like,
right. Yeah, that particular image, it was a derivative of a derivative, so that probably came in the 90s, to be honest.
Okay.
So yeah, some more in there, but that's the idea of when they were able to revise it and use better graphic software by most of it too, right? So yeah, November 5th. Think about this 8 plus months of lava popping up in Hawaiian crater. There it is, and it's gone, and there it is, and it's gone. And it's back, and it's lasting a long time, and lasting longer, but it's not bubbling as much, and the whole pattern of it there. So pretty interesting to think back on. And I bring this up because it makes our 1960s series a little bit more complete. And that this interrupted, this was between 6 and 7, right? So it just shows like when you're having this East Rift activity and summit activity, and it's alternating and filling both areas, it's possible for it to emerge both at the rift or to summit, and either one is fair game. And that's the situation we're in now. Either one is still fair game. It's not a stretch to imagine it popping out of the summit again at any point in the near future if it builds up enough in that area.
One thing we haven't seen, in the past several eruptions now, is it really transitioning from a summit eruption to the rift zone, as we talked about with Maunaloa all the time. Whenever we talk Maunaloa, we're always talking about that transition and its possibility. But with Kilauea recently, it's like not even really been on the table.
Yeah, I mean, Kilauea doesn't behave exactly the same as Maunaloa, right? That's part of what makes them interesting, right? We can put Maunaloa into that pattern, but we can't really do that to Kilauea. Kilauea has eras where it seems like it does a little bit more of that, and eras where it does a little less of that. So it really depends on the era, and it's hard to generalize across eras or across decades or across eruptions, really. I find.
All right. Yeah, we don't have any questions that I've seen that we weren't able to get in chat. And yeah, on that presentation, at least,
Oh, awesome. Yeah, well, we can come back to it in the future. But yeah, that's all that I could find to share today. And I think with that said, yeah, we can maybe wrap it up here.
Yeah. Thanks everybody for tuning in today on our Wednesday pre-Halloween special. Just moved it a day forward just because trying to avoid the holiday, and ran right into the World Series. Ran right into the game of the World Series happening right now. But hey, what can you do? We try. And we appreciate everybody that tuned in today, especially since not a lot's happening on Kilauea, Maunaloa. These are kind of the times where we can dive back into those older files and talk about things that might become more relevant later, like the 1960 series that Phil's been talking about, and then the relevance of that type of thing moving into the last eruption that we had. The timing on that was really pretty superb. So thank you, Phil.
Yeah, I mean, one of the tenets of geology is the past is key to the present, right? So that's why we keep going back to the past to kind of educate ourselves, and that's what makes us all better prepared for whatever happens next. So we're not surprised at what possibly could happen or what might be happening, and our little army can then educate the rest of our community and help each other out when an eruption does happen. That's why we do this. That's our mission as a nonprofit. So I appreciate all your support, everyone tuning in. We stuck here through our almost hour and a half as usual. And yeah, with that said, until next week
Normal
we are
time.
back on Thursday,
normal
time, 5 p.m. on the 7th on Thursday. So until then, unless something surprises us between now and then, from the nonprofit HVERI, Hawaiian Volcano Education and Resilience Institute. Up top, we have Lou and Dane DuPont, and I'm Philip Ong. Until next week, aloha, everyone.